everyone. I Neha Thakkar, Assistant Professor at New LJ Institute of Engineering and Technology. Today we are continue with the Unit 3. Today we are going to see some remaining relational algebra and some additional also. Then also we are going to discuss some relational algebra which will be used for the modification of database. So first we will see the remaining relational algebra. In that one, the first is rename. Rename, that means what? Suppose if we write any relational algebra, we have seen that the output is itself in terms of what? Some relation. But we know that there is no relation of that. That means there is no name of that relation. So if you want to do, or if you want to give a name to that, so we will be having the rename. So the result of the relational algebra are also a relation, but they are not having any name. So that can be done with what? The rename. So it will be specified with what? The Greek letter rho, small Greek letter rho. So the syntax is 3-1. So it is not like that only you can rename or give another name to the relation. You can also give the name to the relational, or we can say the attributes of the relation. So the first syntax is row of x as a subscript and e. So e is what? The expression. That means the relational algebra, any relational algebra expression, whatever is in a output, the x is a new name to that relation. The next is row, then new attribute names, and then e. So e is a expressions. Now you can see that whatever the attributes are there, they are going to be renamed. So here you have to write the sequence of attributes. So according to that, the respective attributes are going to be renamed. The third one is used for the both. You can see that here the x and in parenthesis the new attribute names. That means this is going to be renamed the relation name. That means this is given by the x, and the another one is what? The attributes. So both the things are going to be renamed. Now here e, that means it's not like only the relational algebra expression is there. Whatever the existing relation is there, and if you want to rename it, so you can use this also. Here the relation name can also be there. So this is the use of rename. We will see one example for that. The thing is what? We want to find out the largest salary among all salaries in the employee table. As we are discussing the same relation in previous two lectures also, same we will continue here. So we want to find out the largest salary from what? The employee table. So how we are going to do this? Only one table is there with us. So first we will see that. See, you can see that it is having ID, name, city and salary. So how we are going to do this? So we are going to do the first step, that is the cross product or a Cartesian product of employee with employee only. So first we are going to find out the salary which are not the largest one. So how to do that? So for that we will just do the Cartesian product of employee and employee. Now we have seen that if you are going to combine the relation, and here we are combining it with the itself. So all the attributes are what? Going to be duplicate. So what happen in that? How to identify them? So we are going to use what? Rename for that. So first we will do what? Just do the Cartesian product. We are going to rename either the first relation or the second, and then we are going to apply some condition. So for that, can see that first step is we can now write the temporary relation that consists of the salaries that are not largest. So for that we are going to do first what? The Cartesian product with itself. So you can see that here I have used what? The rename, the row n as a subscript, the d. That means d is a rename, another name of what? Employee. So when I'll write the condition, what I need to do? I need to differentiate the attribute because both having all the attributes are same. So here I want to find out the salaries which are not largest. So what I'll do, salary less than d dot salary. So salary, that means it is the default of the first table, and here d dot salary, that means it's a right side table of the Cartesian product. So this is select with Cartesian product. So here the less than, that means all the salaries which are going to be less, because we have seen that when we are going to use a Cartesian product here and with the same one, so it will be giving us all the combination. That means here there are 4 rows. So it will be again combined with the each row of the second. So here we will get the 16 tuples. But we don't want that, only depending upon this condition. And we want only the salary column in our output, so we have to go for a project. As we have seen, project is used for what? To display the particular attributes, right? So here you can see we have combined all this relational algebra together. The one is Cartesian, then the select and the project. So the output of this is going to be what? This one. Now this is what? This is only the salary of which? The employee. Now output of this is what? The salary which are not a largest one. So by seeing just this, we can say that 25,000 is a larger. So this is not in a output. So this is the step 1. The step 2 is what? We need to find out the largest. That means in output we should have this 25,000. So you can see that if we list the salary of employee table, and if we do what? The minus between those two, as we have seen right previously. So what happened? It will give us what? The answer. So step 2 is to find out the largest salary. So what we are going to do? Just we list the salary from employee table. So for that it is what? The project salary from employee. Then minus, we are going to write a step 1 query. That means that we have find out what? The salary which are not largest. So that we have done with the rename. So the output of that is this, the 25,000 is not that. And here just we have listed the salary of all employees. So this is the output of that. If we are going to do this operation, then what happened? Whatever the data or the values are there in the first, but it's not in a second one. So that will be the 25,000. So that is our output. So that we want the highest or the largest salary of employee table, right? So in this way you can use the rename operator. The next one is a division. The division operation is denoted by this division sign only. Now where it will be used? So mostly it will be used when you will be having some query that in the phrase is what? For all. That means find out something for all employee. So at that time you can go for which operator? The division operator. Now consider here the 3 tables. The first is the employee, which will be having the information of employee, same as the previous one. Another we have added, that is department table. So department is giving what? How many departments are there? So right now the 3 departments are there, D1, D2 and D3. So that is admin, account and teaching. Now what happened? The employee is going to be allocated some department. So that information is going to be here. So employee underscore department. That means we are going to combine this 2 table, employee and department. In that ones you can find that this is the employee ID 101. It will be having in D1 department. Same way this is for 102 and 103. Now it may happen that one employee is allocating more than one department. That means he or she is working in more than one department. So that is also possible. Here you can see that 101 will be having the work in all the department. So we are going to consider this 3 relation. Now we'll see how the division is going to be done. So The information is what we want. The find the employee who involved in all department. So here you can see that the phrase is what all is that for all department, right? So at that time we can go for the division one. So what we are going to do this using the division. Now the first step is what? First we want to know which are the divisions are there. So or we can say which are the departments are there. So that we have seen it will be stored in which table? Department. So directly we can list that department ID from that. So the first is what? First we will find all the department. So R1 equal to, this is project. Why? Because only we want one column or a one attribute from that. So department ID from department. So the output of this will be giving what? All the department, 3 department. Now the second is what? We want to find out the department and name. That means employee name and department pair data. That means which employee is allocating or is working in which department. So that information is not in a one table. You can see that this, if you want this information like 101 is in which department, so that will be in this table only. If you want the name, then you have to combine this to, we can say, the relation. So for that you require the join or a cross product. That means you have to combine this to table. So how to do this? So you can see that employee name and department ID. I have select that too and I have used the natural join. If you are going to use a cross product, then you have to define the condition also. Whatever the common attributes are there, you have to apply the condition. So normally we are using the join and that is natural join. This is. So employee and employee department are going to be combined and we are going to find what? The name and department ID. So from that, this is the output of R2 and this is the output of R1. So you can see that in R2, Ram, it is in D1 department, Sham, that is in D2. So, and here, the R1 output is what? All the department. Now, how the division will work? So, what it will do? It will find out that here in R2, D1, D2 and D3 are belonging to the same employee name. So it will work in that manner. It will do, it is not like the simple division, but how it will be finding the values or a result. So it will just look at all of the departments are available and that is going to be to the same employee. If it will be finding like this matching, then that will be the output. So here you can see that the RAM, it will be having or working in all the department. Here suppose D4 is there. So here RAM and D4 must be there, then and then there will be, it is in a output. So the division will work in this way. So we have seen rename and the division operator. Now database modification. That means if you want to delete something, if you want to insert, if you want to update something in a database. So how to do it with the relational algebra? So first we are going to see the delete. So it removes, right, some tuples from the relation. So how it will be specify? R right side R minus E. So R is a relation and E is what? Some relational expression. That means what? If you want to delete something, it's require what? Some condition. That means delete the employees that are who belongs to Ahmedabad. That means some predicate is there. So here you cannot write simply some tuple. You have to write what? Some relational algebra. So here, as we want to delete the information of employee who are from Ahmedabad, so how to write it? The right side, employee minus E. So first you need to select the employee which belongs to Ahmedabad. So the relational algebra for that, sigma where city equal to Ahmedabad and from employee. Now you are going to subtract it from the table or a relation, that is employee, and again this is the assignment symbol. Again it will be assigning into which table? Employee table. So in this way you can delete it. Here you can use any relational algebra with the condition that you want to delete it. The next one is what? The insertion. So insertion, that means what? You want to insert something. So that will be done by the union. You can see that R is assigned into this right side, that is R union E. So R is the relation and E is what? Any expression, or it can be any values. So right now we'll do what? Insert a one record into employee. So you should know which are the columns or attributes in a employee. So there are four are there: employee ID, name, city and salary. How we are going to specify it? Employee, then employee union. Here the data, or we can say the values for the four attributes, that can be defined with the curly bracket. In that one parenthesis, you have to define the four values separated by comma. Wherever there is a string, you have to define it in a double quotation. So, and use a union to add or insert the data into the table. So in this way the insertion will work. The next is a update. If you want to update something or particular attribute, if you want to update, then the generalized projection will be used. Generalized projection, the form of generalized projection is this, the project, then F1, F2, Fn. So F1, F2 and Fn are what? As we have seen in the previous lectures, they are what? Some, if you want to apply some mathematical operation on particular attribute, then you have to go for this form. This R is a relation on which you want to update particular attribute. So the example, the increase the salary of all employee by 5%. That means whatever the salary of employees are there, you need to increase it by what? 5%. So the projection pi, here some mathematical operation. Here I have used multiplication. Salary will be multiplied by something, whatever you want to do it by the increase, right? So you have to specify here, and here there is a table name, that is employee. Again assign into the same table or a relation, that is employee. So in this way the database modification can be done, that is insert, update and delete. Thank you for watching this video.